Hello everyone, welcome to another video of General Science of Class 10, and today we are going to start carbon and its compounds, that is chapter 4. So, why is carbon such a special element that we are studying in a different chapter? The most important factor or a property that carbon has is that its valency is 4. So, valency of 4 means it can bond with 4 different atoms or maybe 4 similar atoms as well, but it has the capacity to bond with 4 different elements. So, in other cases, like you can also see that silicon also has a valency of 4, but silicon is not as special as carbon. This is because of the size of the carbon atom. Now, carbon atoms are generally smaller than that of silicon, and as a result carbon has a better tendency or a better chance or a better structure to form compounds which only carbon can, and other compounds with or other elements with valency of 4 cannot. So, what makes carbon special is its tetravalency. Tetravalency means it has a valency of 4. Now, the atomic number of carbon is 6, and 6 means it has an electronic configuration of 2.4. So, it has 4 electrons in the outermost shell. It needs 4 more. Now, what type of bond does a carbon atom form? A carbon atom forms a covalent bond. Now, what do you mean by a covalent bond? In our previous classes, we have seen that suppose you want to form a salt, suppose sodium chloride, NaCl. Now, in NaCl, how is the bond formed between sodium and chlorine? So, sodium has valency 2.8.1 is the electronic configuration. Chlorine has 2.8.7. So, it has one extra electron and it needs one electron, then both can become stable. So, what is done? Sodium has 1 electron in the outermost shell. Chlorine has 7 electrons in the outermost shell. So, sodium will donate the electron to chlorine. As a result, sodium becomes positively charged, chlorine becomes negatively charged, and they form a bond, the compound called NaCl, which is neutral because the positive and negative will cancel each other out and the compound becomes neutral. So, here what happened, we have formed 2 ions to get a molecule, and here transfer of electrons have taken place. What carbon does is, it does not transfer or accept electrons, it shares electrons. So, whenever a bond is formed because of the sharing of electrons, those bonds are called covalent bonds. Then what are these bonds called? These bonds are called ionic bonds. When you share ions, when you share electrons which are negatively charged particles, you can form ions. As a result, these sort of bonds are called ionic bonds. Now, carbon forms covalent bonds. Now, what are covalent bonds or how are covalent bonds formed? Let's look into that. Suppose let us consider, there are a few examples given in the book. Let's see how those are formed. For example, hydrogen gas, the molecule H2. So, how is an H2 molecule formed? Now, hydrogen has a valency of 1. So, it has 1 electron in the outermost shell. So, since there are 2, so we have 2. So, what happens here? This hydrogen is 1. If it accepts 1 more electron, it can become like helium. So, it will have 2 electrons in the outermost shell, it becomes like helium and hence it becomes stable. Same with this hydrogen, it also needs 1 electron. Now, if this one donates the electron, then this one becomes stable, but this becomes unstable. The same goes the other way around. If this electron is donated to this hydrogen, then it will have 2 electrons and this electron will go away, it will become unstable. As a result, so that both can become stable, to form a stronger bond between the two elements, what is done is that this hydrogen will share this electron. So, we show it like this hydrogen is sharing this electron. Now, how many electrons does this hydrogen have? 1, 2. So, it has become like helium and it is now stable. This will also do the same thing, this will share this electron. As a result, these 2 electrons are now shared by both the hydrogen atoms. As a result, this sort of bond, the bond that will be formed between these 2 electrons will be called a covalent bond, because electrons have not been transferred, rather they have been shared. So, this sharing of electrons forms a covalent bond. Now, as only a single pair of electron is shared, the bond formed is a single bond. So, it will be H dash H, this dash is showing the bond. So, only single pair of electrons, so single bond. Let us move on to oxygen. Oxygen has a valency of -2. So, it has 6 electrons in the outermost shell. So, oxygen has 6, 1, 2, 3, 4, 5, 6. This oxygen also has 6 electrons in the outermost shell. Now, this oxygen needs 2 electrons to become stable, so that it can have 8 electrons and complete its octet. So it will share these 2 electrons. When it shares, it gets 1, 2, 3, 4, 5, 6, 7, 8 electrons. This will also share 2 electrons from the other oxygen. So now what happens, this oxygen has 1, 2, 3, 4, 5, 6, 7, 8, and this oxygen also has 1, 2, 3, 4, 5, 6, 7, 8. So these 2 pairs of electrons have been shared, and since 2 pairs of electrons have been shared, they form a double bond. So what we have here is oxygen is double bonded to another oxygen to form the molecule O2. Let's move on to another one, that is N2. Nitrogen has 5 electrons in the outermost shell. It has an electronic configuration of 2.5. So it has 1, 2, 3, 4, 5 electrons. Another nitrogen has 1, 2, 3, 4, 5 electrons. So this nitrogen will share these 3 so that it becomes 5 plus 3, 8. And this nitrogen will also share these 3. So this also becomes 5 plus 3, 8. Since 3 pairs of electrons are shared, this forms a triple bond. So N is triple bonded to N to form this compound. Now let's move on to see how carbon can form covalent bonds. So as I have said, carbon has a valency of 4. That means we can express carbon in this way. Valency of 4 means it can bond with 4 elements, right? 4 atoms. So carbon has a valency of 4, so we depict it like this. It's like carbon has 4 arms. And in those 4 arms, it can share with 4 atoms, electrons of 4 atoms it can share. Okay. So now how does carbon form bonds? Let's take the example of the simplest hydrocarbon. Now you may ask, what is hydrocarbon? A compound that contains carbon and hydrogen is called a hydrocarbon. So the simplest hydrocarbon is methane, CH4. Let's see how CH4 is formed. Now carbon has a valency of 4. So carbon has how many electrons? 4 electrons in the outermost shell. Hydrogen has 1 electron in the outermost shell. How many hydrogen do we have? 4 hydrogen. So 1 hydrogen here, 1 here, 1 here, and 1 here. Okay. Now carbon can accept all these electrons, but if hydrogen donates all the electrons, hydrogen becomes unstable. So what to do? Rather share the electrons. If they share the electrons, all of them will become stable, no ions will be formed, and as a result the stability will be higher. So how to do that? Hydrogen needs 2, so it will take this 2, it will take the 2, 2 and 2. So all the hydrogen are now stable, they become like helium. What can carbon do? It will take all the electrons, it will share all the electrons. So now how many does carbon have? Carbon already had 4. And now it has 4 more. So now carbon has got 8 electrons in the outermost shell. As a result, all the elements in this structure are stable. So how the bonds are formed? Here a single bond, single bond, single bond, single bond. So that it can be shown like C, H, 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 H. This is the structure of methane, but this is a planar structure. How they actually form is a tetravalent structure. It's like carbon here, hydrogen, 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 and 1 at the back. It's like a tripod stand. If you have seen a tripod stand, exactly like this, methane is formed. Okay, so this structure is, you will not be asked in the exam. If you are asked, you can draw this structure. This is the structure of methane, a tetrahedral structure. This is called tetrahedral. Okay, so that is how carbon shares electrons with other elements or other atoms. I hope you understood the structure of methane. So now let us move on to see how other elements are formed and what are some of the properties of carbon. Now carbon, as I said, is a tetravalent element. Tetravalent element. So as a result of being tetravalent, it has the property of forming long chains of carbon compounds. Long chains, like you can have a compound called Buckminster fullerene, which contains 6 carbon atoms joined to each other, forming a spherical structure like a football. Only carbon atoms are there. So carbon atoms joined to each other to form a spherical structure having 60 carbon atoms. C60, 60 carbon atoms form a compound called Buckminster fullerene. It is given in your book. It forms a spherical structure like a football, and they form structures. If you see in the diagram, they form structures containing pentagons and hexagons, just like in a football. If you have seen a football, it contains pentagons and hexagons. So it has 12 pentagons and 20 hexagons. Okay, in Buckminster fullerene. Similarly, they form other structures like graphite. Then we have diamond. So these structures contain carbon atoms forming long chains. So if you look into the structure of graphite, how graphite structure is formed, they form hexagonal rings. And all the vertex we have carbon atoms, okay. At all the vertices we have carbon atoms. So they form these hexagonal rings and they form layers of them. Okay. They will have another layer at the bottom. And these will become bonded to each other. So they will form like a layer, one layer over the other. Okay, so sheets of hexagonal rings of only carbon atoms, and these sheets are bonded to each other as well, and that's how they form the structure of a graphite. If you look into the structure of a diamond, if as you have seen in case of methane, the tetrahedral structure, if you see the structure of diamond, the carbon atoms form like this. Okay, then from here we have carbon, right? We have carbons all over. From here again we will have 4 carbons. From here again we will have 4 carbons. Here also we will have 4 carbons. From here again the same structure will repeat, and these structures will go on giving the structure of a diamond. So that's how it is formed. Buckminster fullerene is a spherical structure like a football. Hexagonal rings form graphite, and these tetrahedral structures form diamond. So here you can see that carbon atoms are attached to one another in huge chains. So these structures are actually called the allotropes of carbon, where carbon atoms combine together to form long chain structures. Okay, these are called allotropes of carbon. Graphite, then we have diamond, we have Buckminster fullerene. These are 3 examples of allotropes of carbon. So carbon has this property of forming long chains because of its tetravalency and also its size. As the atomic size of carbon is not huge, it does not produce any hindrance, that is, it does not provide any obstacle while forming bonds with multiple atoms. Okay, as the size is small, it becomes easier for carbon to accommodate more and more carbon atoms nearby, and no hindrance is caused. Hindrance means obstacle. So no obstacle will be caused because it has a smaller size. In case of silicon or other elements having lead is there, which is a valency of 4. So these are big atoms, the size is bigger. Since the size is bigger, it produces some hindrance while forming long chains. But carbon is lucky because carbon size is very small, and hence it can form these long chains without any obstacle or without any hindrance. So now let's see how carbon forms chains, branches and rings. Chains means linear structure of carbon. Branches means you will have, just like a stem has different branches, a structure of carbon can have branches. And rings means circular, just like these hexagonal rings. So let's see how carbon forms those structures. So suppose carbon wants to form bonds with four different carbon atoms forming a straight chain. So it will be like carbon, 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 single bonds, and here we will have, every carbon must have 4 arms, right? As we have seen, carbon has 4 arms. So it will have 1, 2, 3, 4. This carbon already has bonded 2, so it will have 2 empty arms, 2 empty arms, and it will have 3 empty arms. So this carbon has 1, 2, 3, 4 arms. This one is 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So all the carbons here have 4 empty arms. So carbons are attached to each other in straight chain. These empty arms can be filled with any compound that you want. Okay, so any element. Suppose you want to fill it with hydrogen, you can fill it with hydrogen. You want to fill it with chlorine, you can fill it with chlorine, bromine, iodine, whatever you want to fill it up with, you can fill it up. So that is how carbon forms straight chains. Now here it can form branch. How it can form branch? This is a chain structure. These exact 4 carbons can have a branch, just like carbon, carbon, carbon and 1 carbon here. So now this carbon is 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 and 1, 2, 3, 4. So now here you can see this is a straight chain and here a branch has come out. So this is a branch structure. Okay. Now if this one wants to form a ring, what it will do? It will form a square structure, carbon, 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 and here it will have 2 arms remaining, 2 arms, 2 arms and 2 arms. So that's how a ring structure is formed. Okay, so this is a chain structure, this is a branch structure because the branches come out from the original stem, and here we have a ring structure. So that's how carbon can form chains, branches or rings. Now here what we are seeing is these are all single bonded, means only single bonds are present. There is a special structure called benzene. Benzene has the formula of benzene is C6H6. So 6 carbons and 6 hydrogens make up benzene, C6H6. How is the structure? 6 carbons make one hexagonal ring, and each carbon is attached with a hydrogen, single hydrogen with each carbon. Okay, so now we have C6H6, but the problem is carbon must have 4 arms filled, right? It has only 3 arms. Where is the 4th arm? So it forms a double bond with one carbon. Okay, now look at this carbon, it has 1, 2, 3, 4, 4 arms are filled. So no need to form any double bond here. This carbon has 1, 2, 3. So let's form one more double bond. Similarly, this one now has 1, 2, 3, 4. So here you form a double bond. Now if you look into the structure, all the carbon has all the 4 arms filled. Look at this one, 1, 2, 3, 4. This one has 1, 2, 3, 4. This carbon is 1, 2, 3, 4. This carbon is 1, 2, 3, 4. This carbon is 1, 2, 3, 4. And this carbon is 1, 2, 3, 4. So all the carbons are filled and we have double bonds on alternate positions. So these are called alternate double bond structure. So this is a benzene. This structure, this compound is called benzene, having the formula C6H6. So that's how another ring structure is formed, a very important structure. You will get to know the importance of benzene when you move into higher secondary science. If you go into higher secondary science, you will understand how important benzene is, and there are different compounds that you can form from benzene as well. Okay, so I hope it is clear how the carbon forms different structures. Now let's move on to a new topic where we see carbons forming different types of structures, like they contain single bond, double bond, triple bond. So the heading, the big heading is saturated compounds and unsaturated compounds. Now which compounds will you call saturated carbon compounds and unsaturated carbon compounds? So before we move into that, let's talk about another okay, let's start with saturated and unsaturated compounds, then we can move on to others. Now saturated, what do you mean by saturated? Hydrocarbons, as I have mentioned earlier, hydrocarbons are compounds that contain hydrogen and carbon. So there are some carbon compounds or hydrocarbons which are saturated, and there are some hydrocarbons which are unsaturated. Now just by the term saturated, what do you mean? When we have studied about saturated solutions, unsaturated solutions, saturated solution means in which no more solute can be dissolved. Okay, take the example of you take a glass of water and you keep on adding salt to it. You heat the water, after some time you will see that no more salt is getting dissolved. So you heat the water and more salt can be dissolved. A time will reach when excuse me, a time will reach when even if you heat the water, no more salt is getting dissolved. That means the water solution has become saturated. You cannot add anything else into the solution. That is called a saturated solution. Unsaturated means when you can keep on adding more and more substance to the solution or to the solvent and it will get dissolved. So in the same way, a saturated hydrocarbon means a hydrocarbon in which you cannot add any other element or any other atom of any element. And an unsaturated hydrocarbon means a carbon compound where you can add more elements without breaking the compound. Okay, this must be kept in mind. If you don't break the compound, then if you can add more elements without breaking the compound, that compound will be called unsaturated. It will allow you to add more. And if you can't add any more compounds, all the places are filled up, then it is called saturated compound. So here is a structure, let me write. Here is the structure. It contains 3 carbons and 6 hydrogen atoms. All are single bonded. Its name is propane. Okay, we will get to the nomenclature and all in the future. So now, as of now, just look at this structure. It contains 3 carbon atoms and 3 hydrogen atoms. Okay. Now, without breaking any of these bonds, without removing anything, can you add anything else here? You can't, because all the hands of carbon, arms of carbon are filled up. This carbon is 1, 2, 3, 4 arms, all are filled. This carbon is 1, 2, 3, 4 arms, all are filled. This carbon also has 1, 2, 3, 4 arms, all arms are filled up. Hydrogen also has same single bonds. They have only one arm, so they form single bonds. So everything is filled up. You cannot add anything here. That's why it is called a saturated compound. So a hydrocarbon containing only single bonds between carbon atoms. Single bonds, remember the single bonds between carbon atoms. The bonds must be here between the carbon atoms. We don't care about these bonds. The bond between every 2 carbon atom, if these are all single bonds, then these hydrocarbons are called saturated hydrocarbons. Now let's look into one unsaturated one. Suppose this carbon has a double bond structure. So now it has 2 arms, so it has 3, 4 arms. 1, 2, 3, 4. 1, 2, 3, 4. Okay. I hope you are understanding the calculations that I am doing here. 1, 2, 3, 4, 1, 2, 3, 4. Every carbon must have only 4 arms, not less, not more. So this carbon is 1, 2, 3, 4. This carbon is 1, 2, 3, 4. This carbon is 1, 2, 3, 4. Okay. Now you want to add, suppose you want to add one more hydrogen. You could not add any hydrogen here, right? So it is saturated. You want to add one more hydrogen without breaking the structure. So now here, look, this carbon has 4 arms. You can't do anything here. This carbon has 4 arms, but here we have double bond. So if I remove one of the bonds, the compound is not breaking. The compound is staying. Now what? Removing one of the double bonds. Here it has double bond. If we remove one of the double bonds, what we are creating is, now this carbon is how many arms? 3 arms. It frees up one arm of this carbon. And this carbon now has 3 arms, it frees up another arm of the carbon, and we can add 2 new hydrogen atoms here. Just by removing one bond, we are able to add 2 more elements here. That means when it was in double bonded structure, there was a chance that you can add more elements to it, more atoms to the carbon compound. So since it has a chance of adding more elements, that's why the name of the structure is propene. Okay. So this is an unsaturated compound, because now you can add more atoms of any element here. If I look into a triple bond structure, carbon triple bonded to carbon. So this has 3 arms already here. So let's add 1 hydrogen. So it is now 4. This carbon already has 1, 2, 3, 4. So all arms are filled. This carbon is 1, 1, 2, 3. Okay. Its name is propine. Now, what do we do here? I want to add hydrogen. I can add hydrogen. Let me remove one of the bonds. It releases one arm here and one arm here. Hydrogen. I want to remove another bond. So let me remove another bond. Then it frees up 2 more arms. So you can add more and more hydrogen. The more the number of bonds, the more hydrogen you can add. So you don't have more than 3 bonds. The maximum number of bonds formed between any 2 elements is a triple bond. So here also, when it was in this stage, where it had a triple bond, there you had the chance of adding more hydrogen to it. So these 2 structures are unsaturated, and this one is saturated. I hope you now understood what is the meaning of saturated compounds and unsaturated compounds. In simple terms, to make it very easy for you, if any carbon compound has only single bonds between the carbon atoms, these are called saturated. And if any carbon compound has double or triple bond between the carbon atoms, then it is called unsaturated. So I hope that's clear now. Now we will move on to homologous series. In homologous series, what does a homologous series mean? A series of carbon compounds in which the difference between every consecutive carbon compound has a molecular difference of CH2. Let me show you one example. Suppose these 3 compounds, these 3 actually fall, let's move on to, these 3 fall in 3 different homologous series. Okay, so let's move on to one of the homologous series. Suppose I want to form compounds containing 1 carbon, 2 carbon and 3 carbon, all should be saturated. If I want all the carbon atoms to be saturated, then what do I get? Suppose single carbon can form this bond, nothing else. Okay. Double carbon, 2 carbons, and we have 4 arms for each, fill it up with hydrogen. Let's take 3 carbons and all fill it up with hydrogen. So if you look into how many carbons are there, 1 carbon and 4 hydrogen. Here 2 carbons and 6 hydrogens, and here 3 carbons and 8 hydrogens. So what is the difference? In order to reach from this compound to this compound, we have just increased the number of carbon. So it is a series of carbon compounds. What is the difference between this one to this one? It is 1 carbon has been added along with 2 hydrogen, C2, H2 and H4 and H2 make H6. In the same way, if you move from here to here, again CH2 is added. When you have 4 carbon atoms, suppose C4, it will be H10. So it will be plus again CH2. So what is the difference? The difference between every 2 consecutive saturated carbon compounds is actually CH2. So that is why this series of carbon compounds form a homologous series. In the same way, if you check with double bonds, it will form another homologous series. For example, a double bond, you cannot form double bond in this compound because it has only 1 carbon. And as I said, the double bond or single bond should be between carbon atoms. So since there are no second carbon atom, you cannot form a double bond. So it can start from here. So suppose C double bond C, hydrogen. From here we move to 3 carbons. Suppose let's move on to another one, 4 carbons. So now how many is the difference? Here we have C2H4, here it is C3H6, and here it is C4H8. So look at the difference. Again 1 carbon and 2 hydrogen added. Here also we add 1 carbon and 2 hydrogen. See, C2 plus C is C3, H4 plus H2 is H6. Again C3 plus C is C4. And here we have 6 hydrogen and 2 hydrogen, that means 8 hydrogen atoms. So these also fall under a homologous series. Same you will get in case of triple bonded structures. So these single bonded structures fall under one homologous series, these double bonded structures fall under second homologous series, and the triple bonded structures will fall under another homologous series. So now all the single bonded hydrocarbons have a particular name. That homologous series is a particular name, and that name is alkane. Okay, so all the single bonded compounds, carbon compounds are called alkanes. The double bonded ones are called alkenes, and the triple bonded ones are called alkynes. Now if you go back a little bit back in the video, you will see I wrote 3 structures, right? Propane, propene, propyne. The first one was an alkane, the second one was contained double bond, it was an alkene, and the third one was a triple bond, it is alkyne. So you can go back a little bit back in the video to check when I explained saturated and unsaturated compound. I drew 3 structures. Those 3 were of 3 different homologous series. The first one contained only single bonds, so that is why it fell under alkane and hence the name propane. The second one fell under double bonded structure, hence the name came propene because it was under alkene, and the third one came under the triple bond structure, that's why it falls under alkyne and hence the name propyne. Okay, so that's how we name the compounds based on whether they are alkane, alkene or alkyne. Now if a compound contains a single carbon, only a single carbon, it has the name meth. Okay, now if it is alkane, it will be methane. Okay, if it is alkene, it will be methane. If it is alkyne, it will be methine. Okay, now methane and methine don't exist, as I have shown you here. Double bond between a single carbon cannot take place. So single carbon can only form methane. If it has 2 carbon atoms, then it is called eth. Now, if it is under alkane, it will be ethane. If it is under alkene, it will be ethene, and if it is under alkyne, it will be ethyne. 3 carbon atoms, that will be a prop, either propane or propene or propyne, just like the diagram I did. If it has 4 carbon atoms, it goes to butane, butene or butine, based on whether it is alkane, alkene or alkyne. Then 5 will go to pentane, pentene, pentyne. 6 carbons, the 3, 4, 5, 6. 6 carbons will go to hexane, and so on. Okay, so that's how we give the nomenclature. If the compound contains only a single carbon, it goes to meth, and if it has all single bonds, it is methane. If it has 2 carbon atoms, then it is called eth. Now, if it has all single bonds between carbon atoms, then it will be called ethane. Next one will be called, it means if it has 2 bonds, then it will be called, like, okay, look here. If it has single bond like this, it will be called ethane, this one. If it is double bond, it is ethene. If it is triple bond, it is ethyne. Now here, since all the bonds are single, it is propane. If one of them is double bond, then it will be propene. If it is a triple bond, it will be propyne. If this carbon compound contains 4, so it is but. If it has one single double bond, it becomes butene. When it has a single bond, it is butane, and if it is triple bond, it is butyne. So that's how it goes. Any one of the bonds can be either single, double or triple, and based on what type of bond it is, the following names are given. And number of carbon atoms actually give this. 1 carbon means meth, 2 carbons means eth, 3 carbons means prop, 4 carbons means but, 5 means pent, 6 means hex, and so on. So that's how we know about what are the homologous series, 3 types of homologous series, what is the difference between every 2 compound by CH2, and how we give the nomenclature based on the number of carbons and whether it is under alkane, alkyl or alkyne. So that's all we will discuss in today's video. It has been a long video. In our next video, we will go on to see what are functional groups and what are the reactions present in this chapter. So you don't have the full chapter in 2021 HSLC syllabus, so don't have to worry much because the chapter that you are having is very easy. So the tough part, the tough reactions are actually in the part which is not there in the syllabus. So it will be easier for you to finish this chapter. So thank you everyone for watching, and if you have any confusion, make sure you ask me in the comment section. I'll be there to help you out. So thanks again for watching, and until next time, cheers.